Okay, so we're going to have a look at another differentiation rule here with the product rule. Once again, I'd recommend you watch through all the chain rule videos first. So the product rule is fairly straightforward to explain. It's just a way to differentiate functions that have been multiplied together. And we have this general thing up here, which is what you've got to go away and learn. That if you have u times v, then the differential is u dv plus v du. We're going to look at this one here as an example because this is something that we could already differentiate without the product rule. And let's look at the before first, shall we? So before, what we'd have to do with this is expand it out. So we could multiply out those brackets. We could get ourselves to x squared plus 12x plus 35. And then we could differentiate that just using the old multiply by the power and decrease the power. We could get 2x plus 12. So after, we want to use the product rule instead. The product rule would say here, well, we need to say what u and v is. So this is definitely u and v. It's the x plus 5 times the x plus 7. So u is x plus 5 and v is x plus 7. Then according to this, we need to differentiate them both. We're using a dv and a du. So we're going to differentiate u, and that'll just give us 1. We're going to differentiate v, and that'll just give us 1 as well. And then we're going to multiply them by each other. Now, it doesn't really matter the order you do this. The point is that you need to multiply one term by the differential of the other and do that twice. So we're going to multiply u by dv dx and v by du dx. Let's stick to the order we've got in our formula though. So u dv dx is just going to be x plus 5, or 1 times x plus 5, which is going to simplify to x plus 5. And then v du dx is going to be x plus 7, again times 1, so that's going to be x plus 7. Put that all together, we get 2x plus 12. So it does work. But it's probably best using it in situations that we previously couldn't differentiate. So here's a straightforward example. We've got y equals e to the x ln x. So we again define our u and our v to start with. We're saying that u is e to the power of x, and so du by dx would just be also e to the x because it's that shortcut. Well, not even shortcut, just rule. And then v is ln x, and that means that the differential of that is going to be 1 over x. Again, we're going to match up the differential of 1 with the normal version of another. So we're going to have u dv dx. So that's going to be e to the x times 1 over x. And then v du dx, so plus ln x times e to the x. We then want to try and expand and simplify what we've got, but that will give us e to the x over x. I should say this is dy dx we're finding, plus, let's stick the e to the x at the front, e to the x ln x. That's it. Okay, let's try it again. In this case, we have got our u is sine x and our v is 7x cubed minus 5. So we'll say u is sine x and we'll say v is 7x cubed minus 5. We will differentiate them both. So du dx is cos x, that's that rule there. And dv dx is times by the power, so 21x squared. Match them up, multiply them together. So our u dv dx would give us, it's actually right that this is dy dx we're finding. Our u dv dx will give us 21x squared sine x, and our v du dx would give us 7x cubed minus 5 lots of cos x. Okay, good, let's move on. So what's going to make these a bit trickier is if we involve the chain rule in some way. So I've included the shortcuts we talked about in the last lessons on the left there. Let's look how we would differentiate something like this, which looks downright ghastly. Our u is going to be our e to the power of 3x, and our v is going to be our log of x cubed plus 4, because they're just being multiplied by each other. So let's write those out first. We've got u is e to the 3x, and we've got v is ln of x cubed plus 4. And then let's differentiate them both. So our du by dx, again we can use this shortcut here. We want to differentiate 3x, that's 3, and then we just write e to the 3x again. Our dv by dx is always a fraction for a logarithm, so we'll put x cubed plus 4 on the bottom. And then we'll differentiate that and put that on top. So 3x squared on the top, the 4 will go away. Yeah, and that's good. Then we'll match up functions with the differentials of the other. So our u dv dx would be e to the 3x times 3x squared over x cubed plus 4. That is quite unpleasant. And then our v du dx would be 3e to the 3x from the du dx times ln of x cubed plus 4. Probably don't need that bracket actually. Now, if you are being asked to tidy this up, it's worth trying to take out what we'll call common factors. And I can certainly see in this case that I can take out, let's see, we can definitely take out an e to the 3x from both of them. We can also take out a 3 from both of them as well. So if I was looking to fully simplify this, I would have something like this: 3e to the 3x, and then what's left over? X squared over x cubed plus 4 plus ln of x cubed plus 4. There you go, fully producted. Okay, let's try the next one. So our u is our sine 7x, our v is our 3x minus 6 cubed. So we're going to have to use the chain rule again, but we're going to try and use the shortcuts. So we can say that u is sine of 7x, and du by dx there. So with the trig functions, it's going to end up, sine's going to go to cos, so we're going to have cos 7x, and then we're going to end up multiplying it by the differential of 7x, so it's just going to go to 7 cos 7x. V is 3x minus 6 all cubed, so we can use the bracket shortcut. So that's going to go to, let's see, n, so 3. F dash, so the differential of 3x minus 6 is also 3. And then fx, so that's 3x minus 6, to the n minus 1. You can tell that up a little bit. 3 times 3 is obviously 9. So we've got 9 lots of 3x minus 6 all squared. Then we can do the same thing times u by dv. So this is going to give us, for our dy dx, 9 sine 7x 3x minus 6 squared. Now you could obviously put that in different orders. You could put the sine 7x at the end, but that just feels better to me. Plus v du dx, so plus 7 cos 7x 3x minus 6 cubed. There we go. Okay, so let's put absolutely everything together then with this horrible little question. Very welcome to have a go first, but I'm going to go straight ahead with it, I think. So in this case, we have got two clear functions for our u and our v. We've got the cos squared of 3x, and we've got this bracket over here. Let's try and work out du by dx. So we're saying that u is equal to cos squared of 3x. Now this is not something that we've got a shortcut for, so we're going to have to treat this like one of the old chain rule questions. We're going to have to break it down a little bit more. We're going to have to say that u is equal to w squared, because this is cos 3x all squared, and we're going to say that w is equal therefore to cos of 3x. Okay, and then classic chain rule, we want to differentiate each of those two functions, so we'll do that. And cos 3x is going to go to minus 3 sine 3x, that's f dash x at the front, and minus sine x because circular trig. And so multiplying them together would give us minus 6w sine 3x. Now w is not what we want in the final answer here, so we're going to have to substitute this thing back in. So we'll end up with overall minus 6 cos 3x sine 3x. That's going to be our du by dx. Okay, great. Let's do the same with v. So we're saying that v is equal to ln x to the 5, take away 4, all of that to the power of 3. And we can actually use the bracket shortcut here, because if we look at that, we've got a power, which is 3. We've got a function, which is ln of x to the 5, take away 4. Get that bracket right. And we just need to find f dash of x to use that shortcut. So remember, if we differentiate a log, we put the power on the bottom, and then we differentiate that and put it on the top. So we've got 5x to the 4 over x to the 5. 4 will go away to nothing, so that's done. We can simplify that though, and I'm going to. X to the 4 and x to the 5, they'll basically cancel out and just leave us with 5 over x. Okay, great. So if we want to find dv by dx, then that's going to be n, so that's 3, f dash x, so 3 lots of 5 over x, fx, so that's ln x to the 5 minus 4 to the n minus 1, so to the power of 2. And we could tidy it up a little bit and say this is 15 over x, and then I don't think there's much we can do with this, so ln of x to the 5 minus 4 squared, and that's our dv by dx. So we've got u, we've got v, we've got du by dx, and we've got dv by dx. And we're going to do the same thing we've done, match them up, so u is going to go with dv, etc., and then work it out. So we can get overall n, our dy dx, is u times dv dx, so that's going to be, now order of multiplication doesn't really matter, so I'm going to do it in the way which feels best to me. I've got 15 over x, cos squared of 3x, ln of x to the 5 minus 4 squared, okay, that's my u dv dx, plus v du dx. So v, it's got a minus in here actually, so I'm going to change this to a minus. So minus 6 cos 3x sine 3x, ln of x to the 5 minus 4 all cubed. And that is absolutely horrible. Oh well, good fun though, and the chain rule and the product rule put together are a very, very powerful set of tools.